Hi, I'm Catherine Vasquez. Today, I would like to show you a backend project I've been working on. A full-stack REST API built with Node.js, Express, PostgreSQL, Swagger, and OpenAPI. The goal of this project was to build and document a complete REST API with relational data, CRUD operations, testing, and cloud deployment. So I will start with the project structure. The application follows a layered architecture that separates routing, controllers, services, middleware, and database access. Organizing the application this way makes it easier to maintain, test, and scale. This is the main Express application configuration. Here, I configure middleware, JSON parsing, cores, root registration, and Swagger documentation. The API documentation is integrated directly into the application using Swagger. This file is responsible for starting the application. The server establishes the PostgreSQL connection and listens for incoming requests. Environment variables are used to support different deployment environments. The project also includes OpenAPI specification. This file defines the API contract, including endpoints, request bodies, parameters, and responses. Swagger uses this specification to generate interactive documentation. Now, let's move to the live API documentation. The documentation shown here is connected to the deployed API running in the cloud. Every endpoint can be explored and tested directly from the browser. So let's start by retrieving all authors. This endpoint returns all authors stored in the database. Swagger sends the request directly to the deployed API. The response includes identifiers, names, emails, biographies, and timestamps. This confirms that the API is connected to PostgreSQL and returning live data. We can also retrieve individuals' resources. I will request author number 1. The API returns a single record matching the requested identifier. This demonstrates resource retrieval using root parameters. Now let's look at posts. Posts are related to authors through foreign key relationships. Notice that each post includes information from its associated author. This demonstrates relational database design and entity relationships. The API also supports filtering. I will retrieve posts created by author number 1. Only records associated with the author are returned. Filtering endpoints like this are common in production APIs. Comments demonstrate another level of relational data. Each comment belongs to both an author and a post. The response includes related information from multiple tables. This showcases relationship across the database schema. Comments can also be filtered by post. I will request comments from post number 1. The API returns only comments associated with that post. Now I would like to demonstrate a complete CRUD workflow. I will create, retrieve, update, and delete a post using the API. So first, let's create a new post. The request body contains the post data that will be stored in PostgreSQL. Submitting the request creates a new record. The API responds with a successful creation stats. I will use the generate ID for remaining operations. So now let's verify the new record. I will request the post that we just created. The API returns the newly stored record. This confirms that the creation operations succeed. Now let's update the post. I will modify both the title and the content. The API updates the existing database record. A successful response confirms the update. Now let's retrieve the record again. The updated values should now be stored in the database. The modified title and content are returned successfully. Finally, let's delete the record. This operation permanently removes the resource. The API confirms that the deletion was successful. The record has now been removed from the PostgreSQL. Now let's verify that the resource no longer exists. Requesting a deleted resource should return an error. The API correctly responds with a no found message. That confirms that the delete operation completed successfully. Now, let's briefly look at the route layer. Routes define the API endpoints and connect incoming requests to controllers. Controllers handle HTTP requests and responses. This responsibility is to coordinate the flow between the client and the service layer. The service layer contains business logic and database operations. Separating business logics from controllers improves maintainability and testing. The repository also includes complete project documentation. Installation setups, architecture, technologies, and usage instructions are all documented here. This project demonstrates backend development using Node.js, Express, PostgreSQL, OpenAPI, Swagger, and automated testing and cloud deployment. It includes relational database modeling, API documentation, and a complete CRUD workflow. Thank you for watching.